Okay, so let's do question number 3. Question number 3 asks us to check the assumed log normal distribution, whether or not it's reasonable. Okay, so let's see. The point of question number 2 is, so we assumed the wires had this log normal distribution, mu equal to 2, sigma equal to 1. Once we made that assumption, we calculated the same things we calculated in question number 1. However, now, in question number 1, we only had a sample size of 20. In question number 2, we had a sample size of 1,000. So the standard error of these sample statistics is much lower, right, in question number 2. So if this assumption of the log normal distribution, if it's right, then these estimates in question number 2 are better than the estimates of question number 1, because they're based off of 1,000 samples versus these ones are only based off of 20. So in question number 3, we're back to having our original data, and we're just trying to see if the assumptions that were made in question number 2 are they appropriate for this data. Okay, so if it is appropriate for this data, then heck, we could increase our sample size from, right now it's only 1,000. We did 1,000 random samples, but we could increase it to even 100,000 random samples. Estimate these, the mean cable strength, the median cable strength, standard deviation of the cable strength, and the probability that it will break, and we can get really good estimates for those guys. Okay, so let's see, question number 3. First thing I'm going to do is I'm going to change this from saying sheet 3 to question 3. Okay. So first thing we're going to do is create a histogram. Okay, and then that's going to, we know what the histogram of a log normal distribution looks like. It should be skewed. So we want to do the histogram of this, this wire strength, right? All this data. And, this is when the long format is probably useful. Both these tables have the same data. By the way, if you used this long format of the data for question number 1, that's okay. Just make sure that you are matching the cable IDs. So, for example, this is cable ID 1 for wire 1, and this is cable ID 1 for wire 2. So when you're finding the min of the 4 wires, it should all be with the same cable ID number. Okay, so if you're using this data, this long data for question number 1, maybe you're using R or some other program, just make sure that you're matching it by the cable ID number. Really important in order to get number 1 correct. Okay, so we want to go ahead and use this long format of the data. Okay, so I'm going to copy and paste this over here. Double click to make it make the cell width nice looking. Okay, I don't want to give you the answer to this question. So instead of doing it with the real data, I'm going to generate some data here. So you'll do it with the real data. So what I'm doing right now, you're not going to do, right? So let's see. I'm going to generate some data right now. Okay. So I don't want this data to change every time. So I'm going to paste it with only the values. Okay, so now it's not going to change. So that's random data. So this data is not the data that you guys have it. Okay, you want this to be your data in question number 1, or from this original spreadsheet that was provided in Blackboard. You want it to be this data. Okay, so we're trying to create a histogram. Excel has a package that will create histograms for you. So it's kind of nice. If you go to options, so in order to get this package, see, it's called the data analysis package. So in order to get it, you have to go to options, and then add-ins, analysis tool pack, press go, and then press this, click on this analysis tool pack, and then press OK. I already have it, so I'm going to press cancel. But you'll press OK, And when you do that, you go to the data tab up top here, and then you'll have this data analysis thing. Okay. If you don't have that option, okay, you're trying to use Excel in your computer, you got an old Mac or just an older version of Excel, go to a computer in the computer labs at UMBC. They all will be able to get this data analysis tool back. Okay, so my computer's too old. I couldn't get it to work because of an old version of Excel. Not an okay excuse. Okay, you're allowed to use any program you want. If you choose to use Excel, then this data analysis tool pack is going to be extremely useful. You don't actually need to use it to create this histogram. I'm going to show how to do it using that package, but you don't actually need it. There's other ways to do the histogram in Excel. Okay, so and then plus you have the computers in the computer lab that will always have that package. Okay. All right. So first thing in using this package is that we're going to need to come up with our bins. Actually, first thing creating a histogram in general, you need to come up with your bins. So to create the bins, we need to think of first off how many bins we want. We could use the equation n square root of n. So there's 80 data points here. 80 to the 0.5. That's the square root. That's 8.9. Okay, so we might say, okay, so we'll use 9 bins. Now remember, there are such thing as having too many bins, and there's such thing as not having enough. Okay, so you want to use one of the recommended equations to calculate the number of bins. I just use the square root of n. That's I usually start with that. The book has some other recommendations, so go there, check it out. You don't necessarily need to use 9 bins, so just make sure the number of bins that you have makes sense. Too many bins is going to look like your histogram is going to look like someone with broken out teeth. Each bin is only going to have a frequency of 1, and that's not okay. Too few bins, your histogram is just going to look like several bars. Doesn't tell me much about the shape of the data. It's not good either. Okay, so I decided I'm going to use 9 bins. Now I need to figure out the range, so I can divide the range evenly into those 9 bins. So to do that, I'm going to use the min function. I highlight all the data. I highlighted all the data by pressing on this first cell and then pressing Shift Control down. Okay, this is the min. And so then I'm going to do the max. So I press on this first one, and then I press Shift, Control, and then the little down arrow. Okay. There we go. That's the max. So the range is going to be the max minus the min. There it is. Okay. So I should start. So I'm going to write the bin upper limits. Okay. So the upper limits to each of the bins. So I should start with the min, and then, I need to calculate one more thing. Alright, so here, let me label each of these things. So this is the min, this is the max, this is the range, and then I should calculate the bin width. I'm going to right align with those guys. Okay, so the bin width, that's going to be the range divided by the number of bins. So I decided for 9 bins. Alright. So, I can round that, the bin width. Since I'm using Excel, I could keep it exactly what it is. But, rounding, if you round, it's fine. Just make sure you round up. Don't ever round down. Because if you round down, then your bins aren't going to cover all the data. So I should start here with the min. The upper limit should be the min plus the bin width. So I'm going to do 0.5 to 3, round up. Okay. Next one is going to be the previous plus 0.5 to 3. Okay. And now, since this has an equation, which is the previous plus 0.5 to 3, that's the same thing I want the next bin width to be. So I can just drag it, and it'll continue counting the previous plus 0.5 to 3, etc. Okay. So this is bin 1's upper limit, bin 2's upper limit. Okay, so I can drag this. I know I want 9 bins. Okay, so I need to drag that one more. Okay, so now I'm ready to use my histogram data analysis. So I go over here, data analysis. Alright, so I scroll through, I find this histogram one. Okay, I press OK. So at first it'll probably be empty, so I'm going to delete it out so it's empty, as you can see. So input range. So you click there, input range. You're ready to input. So you highlight the first cell, and then you press Shift Control down. Highlights everything in the input range. Input range, that's the data. Bin range. So this is the upper limits. You highlight the first, Shift Control down, highlights it all. So then so you want the output range. You should click on that output range, and then make sure you click in this white in this area here, okay? And then click somewhere on your Excel spreadsheet for the output to go. So I'm gonna click it to be there. All right, and then I'm gonna make sure you press this chart output. That'll make sure that the histogram comes out as a chart, not just a table. So there's the table, okay, and here's the histogram. Now there's a problem here. There's one that's in the more column. So there shouldn't be anyone in the more column because the bins should have covered all of the data. So you see this value here is actually it's below the max. The upper limit to the last bin is below what the max is. Okay, it rounds up to being the max, but it's below what the max value is. So let's see. I'm going to change this to be in plus 0.5 instead of being point. Oh, I see. You see, I round down. I meant that to be plus 0.5 to or 0.53, not 2.3, because 2.3 is less than 2.4. Right? Remember I said never round down because then you won't cover all of your data. So that's exactly what happened here. I round down. I meant it to be 0.53, not 0.523. That's the number that's less than this. Okay, so 0.53. So I'm going to change that to be 0.53. This to be 0.53. Okay, so now I can drag this equation down. Alright, so my last observation here, that's more than the max. Okay, good. So now all my data will be in it. So this histogram, this is no good because of that. Not all of the data fit inside of all the bins. So I'm going to go ahead and delete that. Okay, and if I go to data analysis again, histogram, it automatically picks the areas again. Okay, so I just press OK. And do I want to overwrite existing? Yeah, I do. I want to overwrite what happened before. Okay, so now we see here in the more column there's nothing. That's good. The frequencies should sum up to be the n, the number of data points. So if I do the sum of all of these frequencies, should get it to be 80. Perfect. Okay, so now let's just clean this up, this histogram. So this is what the histogram will look like, or this is what the histogram looks like for my data. Remember, your data is going to look different. Remember, I changed this data here in the beginning. Okay, so go ahead and delete that frequency. The histogram, clearly the bars represent frequency. Okay, and also it's labeled here as frequency, so we don't need that. Bin. Okay, so change this bin to be, it's going to be wire strength for you guys, right? For me, it's not wire strength. It's just random data. So you change it to be wire strength. Okay, random data. Also, we don't need that more over here, so you can delete that by just actually deleting these two, and then automatically it goes away. Histograms, typically the bars are together. Looks better if the bars are together. So we can change this by going to Layout, so Chart Tools, and then Layout. And here, I'm going to make this wider. Is it design? Yeah, it's design. Sorry, not layout, design. Then, so we go to chart layouts. So that's why it's confusing. Chart layouts. It's under design tab. Choose this one where they're all the bars are together. You see it there? If your computer doesn't have that option, it's not that big of a deal. It just makes it look a little better. If we go to format and shape outline, make sure the bars are all highlighted. Okay. So all the bars are highlighted. Shape outline, we can make them have dark outlines. It looks a little better. We go shape fill. We can fill the bars with any color. Lighter color, I think, looks a little better, so that we can see each of the bars. Okay. So we see here, this is what our histogram looks like. So in the next video, I'll show how to do the QQ plot.